So in this section, section 3.7, we are going to look at the chain rule. The chain rule says that if you have a composite function like f of g of x, and you're taking the derivative of that, then you take the derivative of the outer function at the inner function times the derivative of the inner function. So let's see how that can be applied. Now, if you look at this first problem, your inner function is this. This is your inner function. Your outer function is the power function. Okay. So when you take the derivative, what would you do here? You will first do the derivative of the outer function. So you're going to assume that the outer, this is what you have. This is your outer function. So your outer function is a power function, correct? So there is something raised to the power of 10. So what is its derivative? It is nothing but 10 times that something to the power of 9. What was that something? That something was 3x plus 7. And then you have to multiply that with the derivative of the inner function, which happens to be 3. So how would you write this? This is 10 times 3x plus 7 to the power of 9 times 3. And the 3 and the 10 can be multiplied. So this is your final answer. Okay. So here, this can be written as sine x, the whole thing to the power of 5. That's what it is, right? So your outer function is the power, inner function is the sine. So when you take the derivative, what would you do? Outer function is a power function. So apply the power rule. Do not touch the inner function. Okay, so leave it as is times the derivative of the inner function is cosine x. So now this can be now rewritten as 5 times cosine x times sine to the power of 4x. So that is your answer. Now this can be written as 2 plus sine x, the whole thing to the power of 1/2. So again, what happens? This is your outer, this is your inner. So when you take the derivative, your dy dx is going to be outer times the derivative of the inner. Okay, so now if you want to rewrite it so that you change it into the radical form, this will come down like that times cosine x. And if you want to write it even better, you can write it as cosine x over 2 times square root of 2 plus sine x. Okay, so in this problem, they want you to do the following. A table is given. H is the composition of F with G. So that means if I'm doing H prime, how is H prime of X going to look like? H prime of X will be F prime at G times G prime, correct? So now I have to do it all for 3, right? So now so first thing I will do is I'll have to evaluate F prime at G of 3. So what is G of 3? G of 3 is 1, right? Times G prime at 3. This is what I need to do. So what is F prime at 1? It's 5. G prime at 3 is 20. So this gives me 100. Okay. So likewise, how do I do H prime at 2? I will evaluate H prime. So H is F composed with G, correct? So then I will have, this would be F prime at G of 2 times G prime at 2. Okay. Now what is G of 2? Evaluate that first. G of 2 is 5. So I have to do F prime at 5 and G prime at 2. What is F prime at 5? F prime at 5 is -10. G prime at 2 is 10. So again, I have a negative 100. Now, whereas P is so for P prime, this outer function is G and the inner function is F. Okay. So that means this will be G prime at F of 4 times F prime at 4. Now, what is f of 4? F of 4 is 1. So I had to evaluate g prime at 1 times f prime at 4. So what is g prime at 1? It is 2. F prime at 4 is negative 8. So the answer is negative 16. So again, this will be P prime at f of 2 times f prime at 2. So now what is f of 2? F of 2 is 3. So I have to do P prime at 3 and f prime at 2. I'm sorry, G prime. So what is G prime at 3? G prime at 3 is 20. F prime at 2 is 2. I multiply, I get 40. Finally, this is h prime, outer function is f for this. So I have f prime at g of 5 times g prime at 5. So what is g of 5? G of 5 is 2. So I need to do f prime at 2 and g prime at 5. F prime at 2 is 2. G prime at 5 is 20. And 2 times 20 is 40. All right. Okay, here y prime is secant. Secant is the outer function. The derivative of secant is secant times the tangent of the argument, and then times the derivative of the inner function is 3. So your answer will be 3 secant 3x plus 1 tangent 3x plus 1. So this can be written as 2x over 4x minus 3, the whole thing to the power of 1/4. So when you take this derivative, outermost function is the power function. So do that first, okay? And then apply the quotient rule for the inner function. Okay, so then let us see if we can simplify this a little bit. Okay, so this and this are going to get cancelled. So I have negative 6 over 4 is negative 3 halves. And then I can flip this so that this will become 4x minus 3 over 2x to the power of positive coefficient and 4x minus 3 squared. So if I reduce all of this, I will have negative 3 4x minus 3 to the power of, I'm sorry, it'll be in the denominator. So I don't know how much you need to do, but I will just leave it like this. So it will be negative 3 over 2 times 2x to the power of 3/4 and 4x minus 3 to the power of 2 minus 3/4. That is 5/4. So I don't know whether it makes sense to write it like this, but that might be the final answer. Okay, so here the outermost function is again the power function. So I'm going to do that. And then times the derivative of the inner function. Sine squared is itself a chain rule again. So that derivative is 2 sine x cosine x. And that's it. So that will be your answer. Okay, so this one can be written as sine of cosine 3x, the whole thing to the power of 5. So when you take this derivative, the outermost function is this, right? So this is going to be the first outer function. Then when you go inside the inner function, that is also a chain rule. For that, the innermost, so if you are not yet comfortable doing all of this, you can split it up. So then you can think of something else as sine of cosine 3x, correct? So you see how then this becomes the outer and this becomes the inner. So if you take this derivative, it will be cosine of cosine 3x times the derivative of the inner function will be negative sine 3x times 3, right? So that's what you will have. So now if you put them all together, you'll have to bring it all here. So I'm going to write this as, so if you want a little bit of rearrangement here, just to make it prettier, will be negative 3 sine 3x cosine 3x, right? So then that is what is going to go here. So it will be negative 3 sine 3x cosine of cosine 3x. So this finally can be written as negative 15 sine to the power of 4 cosine, sorry, cosine 3x, right? Times sine 3x times cosine of cosine 3x. So that is your answer. Okay, again, this is first outermost is the power rule. Apply that first. Then for the inner, do the quotient rule. X plus 1 times 1 minus x times 1 all over x plus 1 the whole squared. So this is 5 times x over x plus 1 to the power of 4 and x plus 1 minus x over x plus 1 the whole square. X and x gets cancelled away. So I will have 5 times x over x plus 1 to the power of 4 and 1 over x plus 1 squared. You can combine it all and write it as 5 times x to the 4th power over x plus 1 to the power of 6. Okay, now they want the second order derivative here. So let's do the first order first. You have a product, right? A product of this and this. So let's do the product rule. Keep the first term as is and take the derivative of the second term. I'm just splitting it up for you so you can see. Plus, keep the second term as is and take the derivative of the first term. Now, in the second term, I need to do the chain rule. Now here, remember, the square is only on the x, it's not on the cosine. So the outer function is cosine, inner function is x squared. So the derivative will be negative sine x squared times 2x, okay, plus cosine x squared. That's what you have. So if you do this, it will be negative 2x squared sine x squared plus cosine x squared. That's what you have as the first derivative. Now the second derivative will be, do this product. So negative 2x squared times the derivative of sine x squared will be cosine x squared times 2x plus keep the sine x squared and take the derivative of negative 2x squared is negative 4x plus the derivative of cosine x squared will be negative sine x squared times 2x. So if you do all of this, you're going to have negative 4x cubed cosine x squared minus 4x sine x squared minus 2x sine x squared. Okay, so am I right? Okay, so these two can be combined and written as negative 4x cubed cosine x squared minus 6x sine x squared as your final answer.